Today, we explore the fundamental challenges of building decentralized markets. Imagine a user named Leo who wants to bet on the weather. In a traditional system, Leo places his prediction and sends a $100 bet to a central bookmaker. This creates counterparty risk. If the bookmaker turns malicious or simply disappears, Leo's money vanishes. There is no guarantee he will ever see his winnings or even his initial deposit again. This represents a centralized bottleneck. When every participant in a market has to go through a single point of failure, that central entity holds all the power and becomes a massive target for errors or corruption. Decentralization promises a better way, a peer-to-peer network where no single party is in control, distributing trust across many different nodes. But this transition is difficult because we run into the Oracle problem. A smart contract exists on a blockchain, completely isolated from the real world. How can this code verify the final score of a game or the weather without relying on a human middleman? Then there are gas fees. If the cost of the transaction is higher than the potential profit, the market simply cannot function for the average user. Speed is another hurdle. In fast-moving markets, latency is a killer. There is often a long delay between when news breaks and when a transaction is finally confirmed on the chain, making real-time prediction nearly impossible. To create a truly viable decentralized market, we must solve three signature problems. We need reliable, tamper-proof oracles, low transaction fees, and fast confirmation times. The ultimate challenge is achieving all three of these goals without ever sacrificing the core principle of decentralization.
Polymarket's architecture aims for scalability and accessibility. It starts with the user's browser connecting to a MetaMask wallet to sign transactions securely. This design is strictly non-custodial, meaning users always hold their own private keys and maintain full control over their funds at all times. The core of the platform lives on the Polygon PoS chain, which is a high-performance Layer 2 solution. Inside this environment, the market contract and liquidity pool work together in constant sync to facilitate every trade. All value is recorded in a dedicated USDC ledger. By using USDC for all transactions, Polymarket ensures that trade values remain stable and easy to understand. When you choose to buy shares, a transaction flows from your browser to the market contract. The solidity logic within that contract then automatically validates your balance and the current market price. This triggers a transfer of USDC into the ledger, and you can see the ledger highlight as it records the updated state. One of the biggest advantages of this Layer 2 architecture is the cost. Gas fees are consistently under a single cent, which is a massive improvement over traditional blockchain fees. Payouts are handled by specialized redemption logic. When a market is settled, the USDC flows from the ledger directly back to your wallet. These smart contracts are immutable and open source, providing total transparency, while the Polygon network provides the high throughput and low latency needed for a smooth experience. But there is a catch. As secure as these contracts are, they are actually blind to events happening in the real world. While this architecture enables efficient trading, a crucial question remains. How does an isolated smart contract sitting on a blockchain reliably know the outcome of a real-world event like an election or a sports game?
Welcome back. Now we face the Oracle problem. For the Polymarket smart contract to work, we need a way to answer one critical question. How do we know who actually won the event? You see, blockchains are isolated by design. They cannot see what is happening in the real world. This disconnect creates a wall between our digital contract and reality, making it impossible for the code to verify outside results on its own. The simplest answer is solution A, a centralized data feed. Here, a single API provides the results directly to the smart contract. Notice the data packet moving from the source to the contract. It is incredibly fast and cheap to run, but there is a major catch. It introduces a single point of failure. If that one API source is compromised or goes offline, the entire market is at risk. improve security, we can try solution B, a multi-sig committee. Instead of one source, we have multiple validators who must each sign off on the result. An aggregator service collects these individual signatures and sends an M of N proof to the contract. This setup ensures there is no single point of failure, though it still carries the risk that a small group of committee members could collude to cheat. Then there is solution C, the shelling point game. This approach uses a large pool of independent reporters who stake tokens on what they believe the consensus will be. It is mathematically designed so that honesty is the most profitable path, creating a trustless environment where truth equals consensus. However, because we must leave room for a dispute window lasting anywhere from 24 hours to 7 days, this process is very slow. When we look at all three options side by side, the trade-offs become clear. Centralized systems are fast but risky. Multisig offers a middle ground with partial decentralization. The shelling point model gives us high security and trustlessness, but at the cost of being quite slow. Our ultimate goal is to find a way to achieve both high speed and high security. As we move forward, we will look at how Polymarket navigates these choices while balancing the gas costs and finality constraints of the Polygon network.
Polymarket chose a solution renowned for its reliability and decentralization for resolving its markets. By integrating Chainlink with Polygon, they established a robust, decentralized path for determining truth. To see how this works, we can look at the core architecture, the market contract, the Chainlink Decentralized Oracle network, and various independent data sources. The process begins with established connections designed to bridge on-chain logic with real-world data feeds. This resolution request is automatically triggered the moment a market event's scheduled timestamp is reached. A data packet travels from the market contract directly to the Chainlink nodes to initiate the verification process. Rather than trusting a single point of failure, the Oracle nodes query multiple independent data sources simultaneously. Notice how the nodes reach out to source A, B, and C. Even if one source reports a different outcome, like the 0 we see here, the system is specifically designed to handle these discrepancies through redundancy and rigorous checking across the network. The Chainlink network then aggregates these independent responses using a median calculation. You can see the math happening here, where the majority rules. This consensus mechanism is vital because it ensures that no single node or data source can corrupt the final result, providing a secure and tamper-proof resolution for every participant. Once consensus is reached, the final verified outcome is sent back to the market contract on the blockchain. The contract state updates to resolved immediately. This verified data is then permanently pushed back to the Polygon proof-of-stake network to ensure all users can see the final immutable outcome across the entire ecosystem. While the contract is great for secure storage, querying thousands of historical resolutions directly from the blockchain is quite difficult for modern frontends. To solve this, Polymarket utilizes the graph. This service monitors the market contract and creates an optimized index of every resolution event as it occurs on-chain. Now, when a user visits the front end, the browser simply makes a high-speed GraphQL query to the indexer. This ensures that the user interface stays fast and responsive. It provides a transparent way for the UI to display complex historical data without directly taxing the blockchain's limited resources. This streamlined Oracle resolution allows markets to close within just minutes of an event ending. By leveraging Polygon for cost efficiency and Chainlink for decentralized truth, Polymarket has built an architecture capable of industrial-scale prediction. But remember, every complex system has inherent trade-offs that are important to understand as we look deeper into the protocol's design and its future. The robust integration of Chainlink and Polygon ensures trust, but it changes the fundamental economics of trading. We call this the decentralized bill. The first major trade-off is latency. While centralized exchanges operate in under 10 milliseconds, trading on Polygon means waiting for block finality. This roughly 2-second delay means you cannot compete with high-frequency algorithms. However, decentralized architecture wins on cost. Instead of high variable fees, you pay tiny fixed amounts. For smaller traders, this cost efficiency is often worth the sacrifice in raw speed.
This brings us to the transparency paradox. In centralized systems, the order book is private until a trade is executed. On-chain, your intent is public in the mempool before it even happens. This creates front-running, or MEV risks, and preventing this market manipulation requires sophisticated on-chain logic, adding further complexity to the smart contracts. We also face the liquidity challenge. Centralized platforms typically enjoy deep, concentrated pools of capital. Ensuring deep liquidity across thousands of niche decentralized markets is much harder and requires constant incentives for liquidity providers to keep the markets functional. Ultimately, these trade-offs support three core values: transparent odds, global accessibility without gatekeepers, and non-custodial assets. You trade off 2 seconds of latency to ensure you never lose your funds to a bankrupt exchange. The final insight is this: Polymarket isn't trying to be a faster stock exchange. It's trying to be a more honest one. By using decentralized rails, it creates a verifiable record of truth that remains accessible to everyone. It is a fundamental shift from prioritizing the speed of execution to prioritizing the integrity of the market. This honesty is the foundation of a truly global prediction layer.